Now, number 7, find the exact length of the arc intercepted by a central angle of the 60 degrees in a circle with a radius 30 feet. So number 7, the degree measure of the central angle alpha is equal to 60 degrees. And to find the length of the intercepted arc, we need to convert the degree measure to radian measure. So this is equal to 60 degrees times pi over 180 degrees. So it's equal to pi over 3. And the radius is equal to 30 feet. So the arc length is equal to alpha times r, and we get pi over 3 times 30, so it's 10 pi feet. Now let's look at the page 431, problem 108. It's about automobile tire. If a car runs over a nail at 55 miles per hour and the nail is notched in the tire tread 30 inches from the center of the wheel, then what is the angular velocity of the nail in radian measure per hour? So in this problem, we know the linear velocity, that is the 55 miles per hour, and we also know the radius of this wheel, 13 inches, and we need to convert this 30 inches to miles. So page 431, problem 108, we know the linear velocity v, this is equal to 55 miles per hour, and the radius is equal to 13 inches, and 1 inch is equal to 1 over 63360 miles. So we divide this 13 by 63360, and we get this radius in miles. So now we know linear velocity is equal to angular velocity omega times radius. Then we divide both sides by r, then we get angular velocity, which is equal to linear velocity divided by r, and then this is equal to 55 divided by 13 over 63360. Then we multiply both the numerator and denominator by 63360, and these two guys cancel, so you get 55 times 63360 divided by 30, and then you use a calculator to compute this, and then you get 268061.54 radian per hour. Now let's look at the section 5.2 pop quiz. Number 1, what is the reference angle for 120 degrees? We can sketch this angle. Okay, So this is the 90 degrees, right? And followed by the 30 degrees. So this is 120 degrees. Okay. Then this one is the reference angle of this 120 degrees, which is 60 degrees. So the reference angle is 60 degrees. Now number 2, sine of 0 degree. So this guy is equal to 0. Number 3, sine of the negative 60 degrees. We know negative 60 degrees is this angle. Its reference angle is the 60 degrees. And in the quadrant 4, sine is negative. So this sine of the negative 60 degrees is equal to negative sine of 60 degrees. And sine of the 60 degrees is equal to root of 3 over 2. So this guy is equal to negative root of 3 over 2. Now let's look at the number 4, 3 pi over 4. 3 pi over 4, we know its reference angle is equal to pi minus the 3 pi over 4. And this is equal to pi over 4. And you can sketch this angle 3 pi over 4 is here. Okay, this is the 3 pi over 4. So pi minus the 3 pi over 4, then you get this reference angle. That is the pi over 4. And in the quadrant 2, sine is positive. So this sine of the 3 pi over 4 is equal to positive sine of the pi over 4. And this is equal to root of 2 over 2. Now let's look at the number 5, cosine of 90 degrees. With the 90 degrees is a quadrantal angle. Its terminal side is on the positive y-axis, and on the y-axis the x-coordinate is 0. So this cosine of 90 degrees is equal to 0. Now let's look at the number 6. Number 6, negative 2 pi over 3. Let me draw the sketch of this angle. Okay, negative 2 pi over 3 is here. Okay, so the reference angle is this angle. The reference angle theta prime for this problem 6 is equal to pi plus negative 2 pi over 3. So that is equal to pi over 3. And in the quadrant 4, cosine is negative, right? Because the x-coordinate is negative. So this one is equal to negative cosine of pi over 3. And this is equal to negative 1/2.